All right, so some of you were asking today, how do you know when you're supposed to use the inverse trig ratios, or what's the situation that's going to look like? Or some of you might have the opposite question, how can we solve for an angle when we have two sides of a right triangle? So when we talk about trig ratios, just as a reminder, we're talking about the Soh-Cah-Toa, so the sine, cosine, and tangent. This only works in right triangles. So don't use this in non-right triangles. So let's say I have this angle x right here. This side is 9, this side is 8. So if I did have that angle, so if I did have this angle, so this right is an angle. So I'd say, what is 9? So 9 is opposite of that angle. And what is 8? 8 is adjacent to that angle. So then I look at the Soh-Cah-Toa over here and I try to decide which one would I use. So I'm working with O opposite and A adjacent. So that would be tangent. So normally I would set this up as tangent of my angle equals the opposite over adjacent. But because I don't have the angle, we say that we undo this action, right? If it was 5x equals 9 over 8, you would undo that 5 times x to solve for it. So how do we undo? We say we do the inverse of the tangent. So this is really actually saying I take the whole thing and I do the inverse tan of the whole thing. That causes these two things to cancel. So now I have x is equal to the tangent inverse of 9 over 8. Now, the inverse buttons are on your calculator, and they should be like the same button that your sine, cosine, and tangent are. You just have to click the second button first. So you kind of see it says like sine -1, cosine -1, tangent -1. It's not actually -1. It's saying that's the inverse operation of it. So if I do tan inverse of 9 divided by 8, oh, I'm sorry, 9 divided by 8, I get about, so x is about 48.37 degrees. So let's look at another example. So you can always pause this and go back. So let's take a look at another example. Okay, so now let's say my angle is right here. So I'm trying to solve for this angle theta. I'm given this side is 21. I'm given that this side is 5. So I look and I say, okay, if I was trying to solve this, what is 5 to that angle? Well, 5 is the adjacent side. What is 21? 21 is the hypotenuse. So then I look at my Soh-Cah-Toa and I try to figure out which do I use when I'm given the adjacent A and the hypotenuse H. Well, that's going to be cosine. So normally I'd set this up as cosine of my angle equals 5 over 21. But I don't know what my angle is, so I'm going to do the inverse. So cosine inverse of both of these. So then I'm going to have theta equals cosine inverse of 5 over 21. And theta should be about, so second cosine, 5 divided by 21, 76.23. Now, one thing that you can tell if you're doing this correctly is if you accidentally switched the adjacent and hypotenuse around. So you said that your adjacent was 21 and your hypotenuse was 5. If you tried typing in cosine inverse of 21 over 5, try it out. See what you get. You should see something that says error. That's because your hypotenuse always needs to be the biggest side. So that's a way that you can check to see if you're doing this correctly. So you can have an example. So I'll just give you one to try on your own. So if here's my angle, we'll say that that's alpha. This side is 40 and this side is 60. So then think about what are the sides to your angle? So what is 40 to theta? I'm sorry, alpha. So what is 40 to alpha? Is it the opposite, adjacent, or hypotenuse? What is 60? Then set it up as your sine, cosine, or tangent of your angle equals side over side, but then you want to find the inverse. So you're going to be finding the inverse of that.